Ask my instructor 3.6.50. Find the second derivative of this function. There's many ways to handle a problem like this. What I like to do is I like to use a variable to represent the polynomial. That not only saves me from writing the three terms over and over again, but can reduce the possibility of error. However, it's a personal choice. If you want to keep everything as it is, that works as well. You just have to be very careful. Doing it the way that I like to do it, I set u equal to the polynomial that's underneath the radical. And then, since I am looking for a second derivative of y, I need to find du dx and also the second derivative of u with respect to x. So I find du dx, and then I find the second derivative of u with respect to x. And I've changed the look of the problem. The problem looks easier. The only thing I need to be careful about is remembering that u is a function of x. So first I find dy dx. And this is what I get. Now I have to use the chain rule, and again that's because u is a function of x. And I am now ready to look for the second derivative of y. Now, the way that I view it here is the second derivative of y is the derivative of the first derivative of y. So I know what dy dx is, and I'd like to take the derivative of that with respect to x. In order to do that, I'm going to need the product rule, because dy dx is equal to this product of 1/2 u to the negative 1/2 times du dx. So to take the derivative of that, I'm going to need the product rule. So I set up the product rule. I have the derivative of the first times the second plus the first times the derivative of the second. Alright, so I have two terms, and each term is a product of two things. I'm not going to call them factors because there's lots of factors. That's sort of the problem. And I've marked them with colors. So I've got yellow times blue plus yellow times blue. So in the first term, yellow times blue, in the yellow, I'm going to need the chain rule. Now the blue, keep in mind, we know what du dx is. We're just not writing down what it is because we don't need to right now. Now for the second term, we've got yellow and blue again. Now for the yellow, I know what u is. I made that assignment. So I know what u to the negative 1/2 is. I'm just not writing it down yet. And then lastly, I have the derivative with respect to x of du dx. Well, if you think about it, that's just the second derivative of u with respect to x, which I also know. So the only thing I don't know right now is that very first piece that involves the chain rule. So I'm going to leave everything else alone, and I'm just going to take the derivative using the chain rule in that first piece. And this is what I get. So that first yellow line, look down to the first yellow line of the last. Well, I guess it's a line, but I don't want to use the word line too many times. So the derivative with respect to x of 1/2 u to the negative 1/2 power. I bring down the negative 1/2, and that's why I have negative 1/4. And then I have u to the negative 1/2 minus 1. And then, because u is a function of x, I have to add on the chain rule times du dx. And so you notice there's another du dx from the first derivative that I took, but that's marked blue because that's just a copy of the line above it. All right, I'm all done taking derivatives. I actually know what all of these things are. I know what u is, I know what du dx is, I know what the second derivative of u with respect to x is. And so I could do my substitution now, substitute everything in. Well, I kind of prefer not to, because as soon as I do that, it's going to be even uglier than it already is. So what I'd like to work on now are these negative exponents. What I do is I find my most negative exponent, and that's negative 3/2. And I use that to help me decide what to multiply this expression by. I multiply the expression by u to the positive 3/2 over u to the positive 3/2. So I'm not changing the expression, I'm just going to change the way it looks. So I multiply by u to the 3/2 over u to the 3/2. One thing you need to keep in mind is, as ugly as it is, there are only two terms. And so when I distribute that u to the 3/2 that's in the numerator of my fraction, when I distribute that u to the 3/2 into the parentheses, there's only two terms to distribute it to. So I distribute it to the first term and I distribute it to the second term. Alright, after you've done the distributing, for the first term, notice that you have u to the 3/2 and you have u to the negative 3/2. So that gives you u to the, well, to the 0, because 3/2 plus negative 3/2 is 0. And u to the 0 just equals 1. And that's kind of the goal. That's kind of what we're working on. Now for the second term, I have u to the 3/2 and I have u to the negative 1/2. 3/2 plus a negative 1/2 is 1. So that gives me u to the 1 power. And so it's still not very beautiful, but it is cleaned up. To clean it up a little bit more, I multiply the expression by 4 over 4. And again, that means that the 4 in the numerator gets distributed into the two terms. So I'll have 4 times negative 1/4, and I'll have 4 times 1/2. So it's little by little looking cleaner. I am now ready to plug in the u, the du dx, and the second derivative of u with respect to x. And when I do that, I get something that's now pretty manageable. I need to multiply these two binomials. I need to multiply the monomial times the trinomial, and I need to combine like terms. Keep in mind that when you multiply the two binomials, every term is going to be negative because of that negative out in front of the first binomial. And then I've got my trinomial times 2 and times 30x, and that's all going to be positive. Combine my like terms, and I'm finally done.